Hey math kids, today I'm just going to go over some of these properties that you'll be able to use in the proofs that you'll see in the next video. Okay, so I'm just going to go down this list right here. Whoops. And yeah, let's see. All right, we got that. Okay, so we have the reflexive property. Basically, all that's saying is that if we have a line segment AB, we can say that AB is congruent to AB. So that may seem silly to point out, but I'll show you once we get into proofs how this can be useful. Okay. Another one that seems a little silly, but once again, it can be useful, is that all right angles are congruent. So if we have a right triangle right here, 2, 3, or let's do 3, 4, 5, 3, 4, 5. And then we have another right triangle over here, and this is 7, 12, 17 or something. That's probably not a correct right triangle, but just pretend like it is. We have two right angles, and so we know that this and this have the same measure, which we know is 90 degrees, but we can also say that those two right angles are congruent. So if I call this A, B, C, and this D, E, F, then I can say angle ABC is congruent to angle DEF. Okay, so all right angles are congruent. All right. Let's see. Let's just do this. Okay, now the next one, straight angles. All straight angles are congruent. This is very similar to what we just did with the right angles, but if we have a straight angle like this, so 180 degrees, all straight angles are congruent. Okay, so I'm not going to go through that because it's really similar to what we just did with a 90-degree angle. Okay, linear pair. If two angles form a linear pair, they are supplementary. So a linear pair looks like this. So let's say we have A, B, C, D. Since they make a linear pair or they form a line together, we can say that angle ACD let's see. Let's do measurement. So the measurement of angle ACD plus the measurement of angle DCB is equal to 180 degrees, which means that they're supplementary. We could also just say angle ACD and angle DCB are supplementary, which just means they add up to 180 degrees. Okay, vertical angles, those are any angles that make like an X, and they're the angles that are kind of away from each other. So those two angles are congruent. So if I name this A, B, C, D, and E, I could say ACB is congruent to ECD. I should do angles in there. Okay, now triangle sum, that just remembering that all the angles in a triangle add up to 180 degrees. Base angle theorem. If two sides of a triangle are congruent, then the angles opposite these sides are congruent also. So what that's saying, so it says if two sides of a triangle are congruent, so if this is congruent to this, then we also know that the sides that are opposite, so this angle and this angle, are congruent to each other. Okay. Now, if we say it backwards, it's also true. So if we know that this angle is congruent to this angle, then the side that's opposite that angle is congruent to the side that's opposite the other angle. Okay. These are isosceles triangles, if you've heard that term before. Okay. And we only have a couple more until we get into the congruent triangle ones. Let's see. Okay, so we have midpoint. So it says a midpoint divides the line segment in half. So if we have A and B, then we place C, and C is a midpoint. What that means is that AC is congruent to CB. And once again, the reason is because it's a midpoint. All right, the last one right here, angle bisector. An angle bisector divides an angle in half. So it's very similar to this idea of a midpoint, but it's with an angle. And so if we have this, so if we have A, B, C, and then we call this D. If BD is a angle bisector of angle ABC, then angle ABD is congruent to angle CBD. So what that means is if something's defined as an angle bisector, then this angle and this angle will be congruent. So it cuts that angle perfectly in half. All right, now we're going to talk about the congruent triangle theorems. And so if we have two triangles, I know those don't look congruent, but if we know that this side and this side are congruent, and we know that this side and this side are congruent, and we know that this side and this side are congruent, so meaning side, 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 then we can say that both triangles are congruent. So we can make a statement like triangle ABC is congruent to triangle DEF. Okay, so that's the side, side, side theorem, or you can just write SSS. Okay, now if we have a triangle and a triangle, and we do side, and then angle, and then another side, that's called the side angle side theorem. And notice that the angle needs to be in between the two sides. So this is not the same thing. It's not side, side, angle. Okay, that does not work. They have to be like in order. So it has to be side, the next angle, and then the next side as we rotate around the triangle. Okay, now the next one is angle side angle. So if we have a triangle and we do angle side angle, angle side angle, meaning this one, this one. Once again, the side has to be in between. So it has to be angle, then the next side, then the next angle. Yeah, so angle, side, angle. Once again, it would not work if it was angle, side, angle. Okay? Well, not for this theorem, at least. So when you're thinking of angle, side, angle, that's not that situation. We'll talk about where that does work. Okay, now we also have an angle side angle, which is technically what that one up there would have been. So we can go angle, or angle angle side. So as we're rotating around, we can go either direction, but it's angle, angle, side. Angle, angle, side. So this one, like that. So that works. Now if we do this one, see how it could have been angle, angle, and then the next side? So this one would have actually worked, but just with a different theorem. Okay, and then there's also one specific to right triangles. So if you have two right triangles, and then you can do, and you know their hypotenuse is congruent to each other, then you only need to know one leg. Now, really though, let's see. Yeah. So they just call this the hypotenuse leg theorem. Once again, that only works if it's a right triangle. Okay, if you need additional help, come to Math Lab. Until then, calculator.